Hi guys, so welcome back sa ating YouTube channel. So in this video, pag-uusapan natin yung ating 4.7, which is the gradient, divergence, curl, and deflation. So paano hanapin yung mga yun. So even though parang nakita nyo na kung paano hanapin yung gradient, so nagkaroon na rin tayo na idea paano hanapin sa divergence. So parang nabili ganyan yung formula. Din yung curl na hanap na rin natin. So lastly, syempre, hanapin natin si Laplacian. So, lagay natin sila ng konting definition. Kumbaga, sariling topic nila lahat. So, take note, this is just sa ating rectangular coordinate. So, the gradient, divergence, curl, and Laplacian can be solved using polar coordinates, cylindrical coordinates, spherical coordinates. Okay, so, let's have the following. So, let f of x, y, z be a real valued function of and f of x, y, z be a vector field function. So again, dalawang function yung pinag-uusapan natin dito. So yung real valued or the scalar field and the vector field f. So the gradient of f of x, y is given by, so alam natin pag siya yung real valued function, that is simply the gradient is just equal sa partial derivative of f with respect sa x, partial derivative of f with respect sa y, then partial derivative of f with respect sa z. So ayun nating gradient ng f. So note that gradient is only applicable for a real valued function. Pero hindi ako ganun ko sure. So parang kasi pagkakalala ko sa complex dati na naturo ko, something na parang si gradient applicable kay real valued sa vector valued function or sa vector field. Pero since ito lang naman yung sinabi dito, so hindi natin muna i-focus yan kasi yun lang naman yung sabi. Okay, so again, ayan yung ating gradient. So gradient is symbolizes plus ganyan. So yung naka-inverted na triangle. So next is the divergent. So the divergent of f is just simply equal sa vector field f is just equal sa itong symbol na to, which is I think del rather. So del dot f. So take note, del is equal to ganito pala rather. So del is equal to, take note that del is equal to partial derivative with respect to x I plus partial derivative with respect to y j plus partial derivative with respect to z k. Okay, so meaning ng kunyari may function f, input ko lang dyan yung f, kunyari para sa una, no, input ko lang dyan, kunyari yung f natin ay something na parang ano ko lang dito, for example, yung kinuha ko yung del of f of x, y, z, where f is, so this is simply x plus y plus z, for example, ganyan yung given. So pag kinuha ko yung del of f, ang mangyari, apply ko lang. So una, partial derivative with respect sa x nung x plus y plus z, which is 1 times I, so that is 1i, plus partial derivative nung x plus y plus z with respect sa y, the j, so that is 1, then blah blah blah. Ganun yung mangyari dyan. Okay, so tandaan nyo na, yun yung del, yan yung operator, tawag dyan operator, del operator. So makikita mo pa yan sa complex analysis, I guess. So del operator, napaka-importante yan. Okay, so some book using equivalence o parang logical equivalence, so they are using sometimes ganito kasi nga operator siya. So something na, okay, insert mo sa akin isang bagay, gagawin ko ng ganito, lalagyan ko ng i-operate ko using this. Okay, so next is the divergence of the vector field f, no. So the divergence of vector field f is similarly, alam nyo naman, nasabi ko na to, this is just the partial derivative of f sub 1 with respect sa x plus partial derivative with respect sa y ng f sub 2 plus partial derivative with respect sa z ng f sub 3. Okay, so yun yung magiging formula. So nakita naman na natin yan. So next is the curl. So note the curl, parang nabigay ko na rin yung formula, no. So curl is symbolizes as del cross f. So napansin mo, no, del cross f siya. So i-verify natin kung tama yung formula na nakuha natin. So del cross f siya. So ano ang gagawin natin sa del cross f? Ayan. So yung del cross f, so this is just equal sa I, j, k. So ano yung laman ni del? Ang laman ni del, una is yung partial derivative with respect sa x, partial derivative with respect sa y, partial derivative with respect sa z. Okay, din sa ilalim, ano yung laman naman ng f? So ito yung mga yung laman ng f natin can be written as assuming yung f natin, yung vector field natin is yung ating p of x, y, z, j plus q of x, y, z, then j, then plus r of x, y, z, k. Okay, so meaning ito ay P, Q, and R. So check natin kung tatama yung solution. So for I, ano yun? Partial derivative with respect sa y ng R. So ano yung una, no? So this is just equal sa partial derivative with respect sa y nung R. Okay, minus partial derivative with respect sa z nung Q. Tapos multiplied by I. Okay, so check nyo kung tama. Then next is partial derivative with respect sa x ng R. No? So ito ay partial derivative with respect sa x ng R minus partial derivative with respect sa z ng P. Then this is J. So may negative. No, I think may negative. So magiging plus to. So may negative sa labas yan. So assuming na negative J. Then lastly, this is just plus partial derivative with respect sa x ng Q minus partial derivative with respect sa y ng P. This is K. Okay, so check na natin. May negative pa yun. So pag in-arrange natin. So ito napakita ko naman kanina, no? So verify natin kung parehas tayo ng curl. So the curl is partial derivative of R with respect sa y. Okay. Minus partial derivative of Q with respect sa z. Sama I. And partial derivative of P with respect sa y. So yun nga, magiging positive kasi ito kasi dahil sa negative. Then minus partial derivative of R with respect sa x. Then partial derivative of Q with respect sa x minus partial derivative of P with respect sa y. So ganun yung derivation niya. Okay, so imagine na nabigay ng formula. So ito yung gagamitin natin na formula. Then lastly, the Laplacian. So again, meron tayong gradient. So sa gradient para sa scalar field or sa real valued function f of x, y, z. Si divergence ay para sa vector field. Okay, so si curl is para dito sa vector field din na to, in which ito yung form. Okay, kumbaga naka-component form na siya. Okay, then lastly, so basta vector field actually kahit f sub 1, f sub 2, f sub 3 okay lang din naman. So wala naman sila actually pinagkaiba. Yung f sub 1i plus f sub 2j plus f sub 3k, walang pinagkaiba kay pi plus qj plus rk rather. So anong nangyari lang, f sub 1 is yung p, so yung f sub 2 is yung q, then yung f sub 3 is yung r. Tandaan yun ha, yung part na yan. So ayan, ayun yung formula na yan. So next is the Laplacian of f of x, y, z. So note that the Laplacian is can be written as or can be symbolized as the Laplacian of f of x, y, z. So baliktad siya na del. So hindi siya del. So I don't know kung anong tawag dito, kung anong symbol to. So ito yung usual notation niya or something na pwedeng ganito. So sabi nga sa formula, del dot product gradient of f. Okay, so paano yung magiging mangyari dyan? So lumalabas na ito ay just simply partial derivative with respect sa x I plus partial derivative with respect sa y j plus partial derivative with respect sa z k dot product partial derivative nung f sub 1 o nung f, kasi f lang naman tayo dyan, partial derivative nung f with respect sa x, then I plus partial derivative nung f with respect sa y j plus partial derivative nung f with respect sa z k. So pag pinag-dot product natin yan, obviously na mag-multiply lang tong dalawa. So this is just simply partial derivative with respect sa x ng partial derivative of f with respect sa x. Okay, then similar din doon, this is plus partial derivative with respect sa y ng partial derivative with respect sa y ulit ng f, then plus partial derivative with respect sa z of partial derivative of f with respect sa z. So similarly, this is just simply the second partial derivative of f with respect sa x, then plus the second partial derivative of f with respect sa y square plus second partial derivative of f with respect sa z square. So parang meaning dalawang partial derivative with respect sa x, with respect sa y, and with respect sa z. Ganun naman kunin yung ating Laplacian. So tandaan yung part na yan. Okay, so let's have an example. I think kailangan natin example, no? So example, let R be a position vector, so that is x sub I plus y sub j plus c sub k. Okay, so may tanong dito. So kung napansin mo, na alam natin ang position vector is a vector field. So position vector field siya kasi may I, j, k siya. So alam natin applicable lang si position vector para curl sa divergence. So ang possible lang talaga kunin dyan is si curl sa divergence. Pero, paano natin kukunin yung kanyang gradient saka Deflation? So, note na ito ay position vector. Tama? So, ang gagawin natin is something na kaya-create tayo ng function out of that. So, kumbaga, hanap tayo ng function mula dyan. So, consider natin to. Kunyari, kinuha ko yung tawag dito. Kinuha ko yung magnitude ng R tas square. I-square ko lang. Kinuha ko yung magnitude ng R square. So, alam natin na x, y, j, k yan. So, lumalabas na this is just equal sa square root ng x square plus y square plus z square. Tapos may square sa labas. This is just simply equal sa x square plus y square plus z square. So, lumalabas na ito ay R squared. So, this is just A. Kung napansin mo, wala ng ijk. So, dahil wala ng ijk, lumalabas na siya ay tawag doon, lumalabas na siya ay real valued function. So, lumalabas na siya ay real valued function or scalar field. Okay, so kaya ganun yung pinapa-compute. Compute the gradient of the magnitude of R raised to 2. So, meaning ito na yung magnitude of R. So, the gradient is just equal sa, paano ba yung formula ng gradient? Nakalimutan ko agad. The formula of gradient is just equivalent sa partial of f or partial of R with respect sa partial of R with respect lang naman sa ating, so ito yung letter A. Compute ko na lang, no? A. So, the gradient of R squared is just simply sa partial derivative ng x squared with respect sa f. No, so this is partial derivative with respect sa x nung buo. So this is R squared plus partial derivative with respect sa y nung magnitude of R square plus partial derivative with respect sa z nung magnitude nung R square z. So this is simply partial derivative nito with respect sa x, just 2x. Tapos lalagyan pala natin ng I rather. So, lagyan ng I, J, tapos K. Yan. So, this is just 2x I plus 2y J, then plus 2z K. Okay. So, I think ito yung ating gradient. Okay. So, therefore, the gradient is that thing. So, next is the divergence. So, the divergence of R. So, paano naman divergence of R? This is simply ganyan. So, kung napansin mo, symbol ng divergence is just ganyan. So, pwedeng div of R. Pwede yung div of R. Pwede rin naman yung div of R. Pero ito yung ginamit natin kanina, no? So, the div of R. So, paano natin kunin yung div of R? So, this is simply yung R na yun, kunin natin yung partial derivative niya with respect sa x. So, this is just equivalent lang sa partial derivative. No? So, that is partial derivative with respect sa x nung x para sa una plus partial derivative with respect sa y nung y para sa pangalawa, then plus partial derivative with respect sa z nung z. So this is just simply equal sa 1 plus 1 plus 1 which is equal sa 3. So note na hindi laging sagot dito is number. Okay, so pwede pa rin magkaroon ako ng x plus y plus z, okay lang din naman yun. So anong nangyari lang dito, so divergence nagiging scalar. So kung napansin mo sa gradient, so from real valued function, ginagawa niyang vector valued function. So kunyari, yung real valued function, kukuha na ko ng gradient, gagawin siyang vector valued function. Okay, so nangyari naman dito pagdating sa divergence, from vector valued function R, ginagawa naman siyang real valued function. So meaning minsan scalar pa. Ganun yung nangyayari actually. Okay, so for letter C, yung curl. So paano yung curl natin? So this is B cross R. So, curl of R. So, paano sa curl of R? Ayun lang, sundin natin yung formula sa taas. This is just equal sa partial of R with respect sa Y. So, lumalabas na ito yung R. So, yun na, PQR. So, kanina ginamit ko sa F sub 1, F sub 2, F sub 3. So, PQR naman siya ngayon. So, una is partial derivative of R with respect sa Y. So, una is partial derivative of R is Z. With respect sa Y is 0. Minus partial derivative of Q. So, ito yung Q with respect sa x. So this is simply also 0. So this is just 0. Then I. Then minus partial derivative. Partial derivative ba ginamit ko? Minus po o plus? Plus and plus rather. Plus plus partial derivative ng p with respect sa z. So, partial derivative ng p with respect sa z, so this is just 0. Then minus partial derivative ng r with respect sa x. So this is just 0 ulit. 0, this is just j. Then plus partial derivative ng q with respect sa x. So this is just yung q yung pangalawa, so this is 0 pa rin. Then minus partial derivative of p with respect sa y, this is just 0 pa rin. Okay, this is k. So meaning, lumalabas na ito ay 0i plus 0j plus 0k, or simply this is the 0 vector. So yan na, this is just a 0 vector. So tandaan, ang cross product o yung curl is laging vector valued. So 0 vector yung lumabas sa kanya. So for letter D, ano naman gagawin sa letter D? So find the Laplacian. So the Laplacian of r squared. So baliktad pala. The Laplacian of magnitude r squared. So para natin kunin yung Laplacian yan. So kunin natin ang second partial derivative. So kunin natin yung second partial derivative. This is second partial derivative with respect sa x squared nung r squared plus second partial derivative with respect sa x squared nung magnitude of r squared plus second partial derivative with respect sa z squared. This is r squared. So ito na yung r squared natin. So anong nangyari? Kukunin na natin yung, diba, yung first derivative niya with respect sa x ay yung lumabas. So ano pasin mo, isa sa technique dito, mangyari dito, yung lalabas dito yung first derivative. So mangyari yung first derivative is ito, 2x 2y 2z. So first derivative niya is 2x 2y 2z. So parang nangyari, nakatulong na yung ating gradient. So after nun, mula sa gradient, kunin ulit yung derivative. So with respect sa x. So derivative na to with respect sa x. So this is just equal lang naman sa 2. Kasi derivative ng 2x with respect sa x ulit is 2. Plus derivative ng 2y with respect sa y is just 2. Then derivative ng 2z with respect sa z is just 2. Okay, which is this just equal sa 6. So note na ang Laplacian, ang sinasagot naman lagi ni Laplacian is laging scalar field or something na real valued function. So hindi vector yung sagot dyan sa Laplacian. So tandaan yung mga bagay na yan. So note na ayan yung ating pagkuha. Okay, so let's have theorem, no? For any smooth real valued function f of x, y, z, so yung del cross del of f is equal to 0 vector. So yun yung problema natin. So paano natin ipo-prove to? So yung del. So note, ito yung proof. Okay, so we see that the smoothness. So smooth naman yung f. So we can have del cross del f. So kung ba kinuha ko na yung del f, kinuha ko na yung, diba yung del f? Ang del f natin is yung gradient. Okay, so yung gradient na. So since gradient siya, alam natin vector field siya. So this is I, J, K. Okay, so para sa del, ano yung del natin? This is the partial derivative with respect sa f, with respect sa x, partial derivative with respect sa y, partial derivative with respect sa z. Para dito. Then para sa del of f, naman, this is something na partial derivative of f with respect sa x, and partial derivative of f with respect sa y, and partial derivative of f with respect sa z. Okay, so paano natin sasagutin yung part na yan? So lumalabas na mangyari, itong una, this is just equal sa una, partial derivative. So partial derivative with respect sa y ng part ng f with respect sa z. So dalawa lumalabas. So this is just partial derivative of f with respect una sa y, then partial derivative with respect sa z, minus partial derivative naman ng f with respect una naman sa z, then with respect sa y. So sir, paano ko nalaman na z una? Kasi nangyari, ito yung operator. Tanda mo, ito yung operator. So ito yung papasok. So meaning partial derivative with respect sa y of partial derivative of f with respect sa z. So anong nangyari? Ito yung nangyari. So napansin mo na yung y yung nauna. So pagdating dito, ito yung operator, ito yung papasok. So meaning z yung huli, tapos z yung una, then z yung una, y yung huli. So yun yung papasok. This is just I. So tandaan yan. Then plus next is yung dulo-dulo. So partial derivative of x naman to, no? Partial derivative of f. So ito ay syempre x para doon, then partial derivative with z, minus partial derivative nung f ito y to, no? So this is partial derivative of f with respect sa partial derivative of y dito. Ay, ito pala una. Ito, no? So partial derivative of f with respect sa z, then partial derivative of z with respect sa y. So this is x then rather. This is z, then partial derivative of x. Then this is just negative j, then plus, hirap mag-prove, this is partial derivative na to with respect sa x, then y. So partial derivative of f with respect sa x, then with respect sa y, then minus partial derivative of f with respect sa y, then with respect sa x. So note na hindi ko to nasabi sa inyo, no? So whenever sinabi na yung function natin is smooth function siya. So, di ba sinabi ko naman sa smooth curve function siya. So, yung mixed partial derivative natin, pag smooth, yung mixed partial derivative natin na ganito, partial derivative with respect sa x, with respect sa y, is equal sa partial derivative with respect sa y, with respect sa x. Whenever f is smooth, when f is defined to be smooth. Okay, so whenever pag part sa definition na siya ay smooth, automatic na yung mixed partial derivative niya is equal. Okay, so regardless na kahit magkabalik-balik ta dyan, so as long yan. So meaning, ito ay lumalabas na yung partial derivative of f with respect sa y, with respect sa z ay equal lang dito. So lumalabas na ito ay 0, 0, then 0. So kahit ano mangyari, this is just simply 0i. Okay, then plus 0 times negative j plus 0k, or simply this is just the 0 vector. And this is done. Okay? So, ganun yung ginagawa pagdating dito. So, check pa natin kung may susunod pa tayong discussion. Yun, may susunod pa naman pala. Okay, so next is something about the Theorem 4.7.2. So the vector field f of x, y, z has a potential, then curl of f is equal to 0. So yun nga. Pag meron siyang f of x, y has a potential, yung curl ng f is equal to 0. Tandaan, napakalaking tulong yan. So imagine mo ha, pag pinapahanap ko sa yung curl of f, so instead na hanapin mo yung curl of f sa mahabang paraan, check mo na kung may potential. So pag nahanap yung potential, automatic yung curl of f is equal to 0 vector. So curl of f is 0 vector, hindi 0. So tandaan na, 0 vector siya. Then for theorem 4.7.3, so for any smooth vector field, so vector field f of x, y, z, yung del dot curl of f, so curl yan del dot curl of f is the 0. So yun, tama na naman yan. So kayo na din mag-determine paano nangyari yan. So since smooth siya, alam na yun, mixed partial derivative is equal. Okay, sa pag pinrove yan. Tapos yung dahil dot product to, so lumalabas na hindi siya vector yung kakalabasan. Kasi yung main operator natin is dot product. So, vector times vector, vector dot product vector is scalar. Okay, dito naman is something na vector yan. Kasi curl of f lang naman yung hinahanap. Okay, then lastly, corollary 4.7.3. So, if the flux of a curl of a smooth vector field f of x, y through any closed surface is 0. So, you don't know the flux of the curl. So, the flux of the curl of a smooth vector field f of x, y, z through any closed surface is 0. So, paano ba natin kumpitin yung flux? So, yung flux is something na yung integral, no? Integral of f dot dr. Something na ganun. So, dot dq dot dc. So, let lang muna tayo dito, no? So, for proof. Green ako gagamit. So, let tayo na let sigma be a closed surface which bounds a solid S. Okay, so the flux of curl of a smooth vector, the flux of the curl of the smooth vector. So flux na, so flux, so meaning yung flux daw niya, so double integral nung delta cross f dot d sigma. Okay, kasi ito yung tinatawag natin na flux doon sa part na yun. So it's just equal sa, ngayon pansinin niyo ha, so since ito ay vector, so on that product ng vector, diba vector si del, vector din si f. So, vector yan, vector field yan. So, nangyari, yung dot product, cross product na yung dalawang yan is vector. So, vector din ito is something alam natin. Now, using divergence theorem, so by divergence theorem, this is just equal sa triple integral. So, gagawin ko siya, since solid sinabi kasi solid. So, since sinabi ko sa solid S siya, so closed surface So, since closed surface, alam ko na solid siya. So, sa solid natin is just equal sa, this is just equal sa dot ng del cross F, then dB. Okay, so ano nangyari? Ano yung nangyari na ginawa natin? So, naalala nyo, divergence nung part na yun. So, ito yung lumalabas na divergence. Ito yung divergence. Ito yung dib. So, yung ganyan part na yan, ito yung dive of o divergence of del cross F. Ayan yun. So, note na yun yung divergence. Okay, and we all know that, sabi nga nila, sabi nga ng isang theorem natin kanina, so, napansin nyo, sabi ng theorem kanina, for any smooth real-valued function, yung del of f is equal to 0 vector. So, theorem 4.17. So, check ko lang kung anong theorem to. Hindi ko nasa. Diyan, rather. Dito. So, sabi na, for any smooth vector field, f of x, y, z, yung del cross f is equal to 0. O yung divergence ng del cross f is divergence ng curl of f. Ganun ibig sabihin, divergence of curl of f. Kasi yan, parang ganito. Divergence of curl of f is equal to 0. So, note na ito yun. So, divergence of curl of f is just equal to 0. Bakit? Kasi siya is smooth. Let S be a smooth vector field. So, this is just by theorem integral over S. This is just 0 d b. So, by theorem 4.73. So, this is just equal sa 0. So, therefore, this is done. So, through any, so sabi ulit, the flux of the curl of a smooth vector field f of x, y, z through any closed surface is 0. So, closed surface yung dinefine ko. So, let sigma be a closed surface which bounds a solid S. Then, ito yung kanya. So, napansin nyo na yung flux of f. So, flux ng vector field f, ito yun. So, flux is ito mismo yung buo. So, ito yung curl ng vector field f. Ito yung curl ng vector field f. Ito yung flux, yung buo. Okay, then using divergence theorem, by divergence theorem, lumabas to. Now, that is divergence of nung sa loob, then dB. Then, using yung theorem na to, lumabas na 0 yun. Then, therefore, yung buong integral is just, o yung buong triple integral is just 0. Okay, so that's all in this video. So, hoping na panoorin mo pa yung next video natin. So, next video natin is about the gradient, curl, divergence, and Laplacian in cylindrical and spherical coordinates. So, ito na yung may papakilala ko sa inyo na orthonormal vector. Tandaan yan. Okay, so again, thank you for watching. Hoping na nag-enjoy ka.